Okay, good morning again. Welcome. And I'm Mr. Lai. You can call me Wei Boon. I'm quality engineer and quality manager in charge in Bossard, Malaysia. I have over tens of years in this fastening technologies. In between, I've been working in a different field, exposed in this operation risk management. Certified under this ABCP, Associate Business Continuity Professionals, okay, under DRI. This is something special, okay. So, like I mentioned, this is our 3C webinar series, and we have completed the first one last week on 29 April, talking about compliance, okay, save our Mother Earth, okay. For those who have followed and joined today against this webinar series number 2, welcome and thanks for your support. And with the themes of, because we are still fighting the COVID, okay, we are heading for this theme, fastening for a better future. And today we're going to address the second topic of this second series, which is coating and cleanliness. We're talking about protections and preventions. Okay, well, since this is COVID-19 situation, okay, I believe all of us, okay, all of us, including myself, okay, these are the two best practices that we have nowadays. Okay, today's entered the 50 days for those who already lost count. This is 50 days of lockdown or MCO, and we are practicing wearing masks, washing hands. Okay, how is it relevant to our webinar topic today? Putting a mask in front of us is like putting a coating in front of our face. We try to prevent or protect ourselves, attacked by the virus. Washing hands is a cleanliness. Okay, so we try to wash away as much as possible all the harmful bacteria, prevent us to get COVID-19. Okay, so in terms of mask and coating, in fact, surgical masks nowadays, again, I think everybody familiar with the mask, either it's 2-ply, 3-plies, okay, and the best, of course, you should have N95, but for public like us, we don't need. And for those who have followed my first series of webinar, okay, I hope you still remember the coating anatomy. Okay, we're also talking about different layer. The first layer, the chromate layer. Okay, so that was presented last week. Okay, I hope you still follow on this. What I call understand or remember this thing. And in terms of mask, of course, besides the surgical mask or N95, there are a lot of different masks. Likewise, coating, we have a lot of coating in the fastener industry. Okay, wide range, different color, okay, different performance. But we are talking about 3 things over here: compatibility, resistance, and also thickness. Later we explore how it goes. In terms of washing versus the cleanliness, okay, and again I said you should have practiced your own washing methods, and I believe you still practice the 20-second washing to make sure your hand is clean. Okay, and using the sanitizer is important. Keep ourselves hand clean, kill all the germs. Okay, in fact, there's a study, different activity you need to clean differently in terms of frequency. So, but unfortunately, you will not kill 100% still. Okay, so we are talking about intensity, the cleanliness level in this case. And wow, don't be scared of this hand, like the ghost hand, right? It's a hand under the ultraviolet, okay, to see how good you clean your hands. Okay, beware, wash your hand with care. Now the question is, how clean is clean? Okay, we'll explore this later. So, wow, this guy coming back again in my first webinar, first series. Okay, if you still don't have your haircut, maybe you can end up like this. But there's a feature over here: coating, the compatibility, resistance, thickness, cleanliness, frequency, intensity. But today we're talking about these 2 topics. Okay, and then rest assured, okay, nowadays the mask and sanitizer will not be out of stock. Should be, okay, it's easily available. And the key consideration in the fasteners today, it's a very wide topic, wide topic, very what do you call big scope. So today I'm going to touch on, okay, there are fundamental, technical, application, and basic rule of design. Okay, so there are a little bit here and there to explore what are the key considerations in fasteners in technology or industry. Okay, I hope so far so good. Okay, we are going to move into the fundamental understanding of coating. Okay, so today, as I mentioned earlier, okay, the fastener coating variety have blossomed. Okay, so a lot of varieties. And if you still can recall, my first webinar series are talking about original zinc plating have no color. Then after chromatizing, it turned into different colors. And also show this. We also show this source spray test versus the plating thickness. Source spray test according to ISO 9227. So if you plate your fastener, let's say zinc blue 5 micron, you can go up to 50 hours before it get rusty. Okay, so this is how the chart been interpreted. I pull out my pen first so you can see clearer. Okay, so okay, if you plate 5 micron here, you should have 50 hours of soft spray test before it turn rusty. This is the meaning. And of course, ISO 9227 is one of the standard. You can refer to other standard, but other standard more or less the same. Okay. Now the question is, can we plate or coat the screw with thicker plating so that it can perform better? Because I showed the chart just now. You know, the higher plating you coat, you know, the what I call resistant to the hour resistant to the rust is higher. So yes or no? Can we plate the screw with thicker plating? Key in 1 for yes. Try the chatbot. Okay, I encourage you to explore your chatbot right now. Okay, if you think that is no, you cannot. Key in number 2. Okay, I will review the answer later. I give you 10 seconds. Okay, so the question, I go back to this chart. Okay, 5 microns, 50, 10 micron, you can go to almost 100. 15 micron, you can go up to 150. So the question is, can we plate thicker so that it can perform better? Okay, so small screw with thick plating to increase source spray test. Let's say customer have M3 screw. You ask, say, Bossard, can you give me this screw with 500 micron zinc black plating? Oh dear. Of course. Well, I'm just afraid that instead of giving our customer a zinc black plated screw, perhaps it will become a black stone because it's too thick. Of course, this example is too exaggerated. In a plating world, it's not the thicker the merrier. Okay, you cannot plate. Simply there's a guideline behind it. Just like wearing a mask. Okay, just how I showed this, a beautiful lady wearing a mask, a proper surgical mask. Do you need very thick mask over here? Compared with this cheeky boy, okay, wearing I don't know what kind of material, very thick. Which one is safer? Okay, so in terms of performance, not the thicker the merrier. So there is a standard should be respected. Okay, with different plating and different size of the screw. Okay, this is a table, a simple table. I compare the size of screw over here from 1.6 to M20. The maximum plating thickness allowed, okay, from 3 micron, 5, 8, and 10, depending on the size. And then over here is a property class. So in general, if you're talking about property class less than 10.9, okay, then you should have very common zinc or nickel plating up to M10. But if you want to plate beyond 8.8, you should have phosphating. The reason being, okay, if you electroplate of this what I call property class, you could have a, we call it as a HE risk. Okay, sorry for my handwriting. I'm using mouse to write this. HE, this is hydrogen embrittlement. Okay, I will not elaborate a bit more because this is silent killer or one of the biggest risks in fastener industry. So if you use phosphating, it's okay. Okay, and then if you have bigger boats, you're talking about M20. Okay, then you can plate maximum 10 micron or even more. Okay, depending on the size. Okay, so hot dip galvanized is allowed. But if you want to avoid HE, you have other options: delta tone, steel, geomet. This is not electroplated. It safely can plate for 10.9 and above. And if your product allowed to use a higher grade, sometimes not necessarily your fastener need to be plate. You can choose directly stainless steel. Don't need plate. The material itself stainless steel. It's good in corrosion resistance. Later we'll talk about this stainless steel. Okay, so mask coating. I believe you have a brief idea. Okay, we wear masks to fight COVID-19. Now we apply coating on fastener. What are we fighting against? Okay, yes, I'm asking you questions, but I'm going to answer myself. Okay, if you have answer in your heart now. If you apply coating on fastener, what are we fighting against? Corrosions. Okay, how corrosion can happen? Not because of we choose one material, zinc plating, not good, you corrode. Okay, there's a lot of material according to this periodic table. A lot of material, zinc is just one of them. Nickel, cadmium, and etc. Okay, material is just only one of the factors. Material fail is not necessarily the material fault. It could be the environment. Are we using the product onto the right environment? Okay, is it outdoor? Is it indoor? Is it harsh environment? Is it high humid? So this need to be considered. And of course, last but not least, reactions. You have material, you have environment. There will be the reactions. Okay, rust. We are talking about ferrum oxide. When ferrum interact with the oxygens to form a ferrum oxide, it's called rust. So these three factors must come into a picture to enable the corrosions. Okay, so I hope to give you a little bit of picture. Okay, not only the plating itself, three factors must come. The factors. So let me quote you a very interesting example. Okay, we have one customer that are doing a LED board. Okay. The board that you go to any restaurant, any outlet, they put outside and then put it in the what called the promotion of the shop of the day. Okay, the statement I put here: improvement that getting worse in performance. Why I say so? Initially, customer just assemble this board with this is joint here. Okay, with a zinc plating screw. Because it's put outdoor. Okay, outdoor environment, the zinc plating starting to have a little bit rust. Okay. As you can see here, a little bit rust. Customer said, not good, because the end customer complained. Wait, a little bit rust. Okay, can you do something? Yeah, according to my understanding, stainless steel is the best. So the customer just changed to stainless steel. Oops, you can see, worse. How come? Because they never consider another factor called reactions. There is a reaction between the plated part of this joint and the screw. Though the screw survive, but it accelerates the corrosions of the joint. Okay, this is known as galvanic corrosions. Okay, so you need to consider these factors. Okay, whenever you choose a fastener, even though it's better stainless steel in this case. Okay, indoor outdoor application. This is a short basic design rules. Okay, indoor outdoor application. If you are using outdoor, let's take outdoor route. Okay, this is outdoor. Okay, so you can choose a galvanic hot dip galvanized. Okay, so it's a little bit ugly because it's used in outdoor. But if your product is high end, you want to use something better, stainless steel always better. In this case, as you can see, okay, small little marking here, A2. Okay, but if your application is close to coastal, like now you are in Penang, okay, Penang Island, close to coastal, seaside, you should use A4 type stainless steel. So it's different, yeah. A lot of time, being a professional like me, I always look at outside application and I look at how they fasten the joint or the structure. They use A2, close to seaside. Oh, I know, it's designed to fail. Because stainless steel will fail when you're exposed to A2 stainless steel will fail when you're exposed to seaside environment. Okay, and then harsh environment, we're talking about different chemical or high humid temperature. Okay, there's a different coating, Teflons, okay, geomet, things like that. Okay, so if you look at if you are looking at indoor application, you need to consider assembled material. If it's plastic, don't use fastener with oil finishing because you will react with the plastic, the oil residue. Okay, metal. The fasten joint load is a key design concern in the product. It's another aspect. In fact, this is very simple guidelines. Okay, the total picture of this selection is a bit more complicated. You can imagine. I don't want to show this. Okay, we have no time to explore one by one. What is yes, what is no. Okay, so I go back to the three considered factors: material, environment, reactions. It's very important. Okay. Hello participants, thanks for staying with us on this webinar replay, and I hope you are clear with the fundamental of our coating presented just now. Before we moving into the next chapter, I would like to remind you to key in your question in case you have any into the chat box so that our engineers and also the salesperson able to pick up an immediate address to you. Okay, the next chapter we're talking about fundamental understanding of cleanliness. With that, I end my fundamental understanding of coating. Now I'm moving to this another topic, second topic, cleanliness. Okay, cleanliness. This looks familiar, this slide. Those who follow my first webinar, the advancement of electrical product. Today, nowadays, one of the most appealing element is the product downsizing. Okay, big phone. Okay, the camera all already designed in one, all in one simplicity. What does it mean? As the assembly part become ever smaller, okay? You can see you break down the what I call the cell phone, okay? You can see a lot of small little components. All these components are very sensitive to microscopic particles, okay? Even a particle 500 micron, 200, or even 100 micron can cause a malfunction of the product. Therefore, a technical cleaning is increasing important in the design of producing the fastener for fastening technology. So there are various industry standards defined for different industry, according to standard ISO and also some specific industry standards, for example VDA, for different applications. And earlier years, you know that cleanliness only apply for microelectronics products, medical, and food. These are very common. But nowadays, you can see aerospace, automotive also have this requirement slowly. Why? Because there are more and more microelectronics chips or stuff built in to the product. Car one day is no longer just a car. It's a movable, I would say, computer or laptop, whatever you call it. Okay, autonomous car. Okay, so when you have a cleanliness, what I call requirement, you should have a space, a clean, we call clean room. Clean room is defined airborne contaminations control environment, okay, confined place to certain level appropriate for accomplish a contamination sensitive activities. Okay, sorry for a little bit of technical definition. There is a good standard you can refer to, ISO 14644, define different clean room, what I call class, ISO 1 until ISO 9, okay, and against different particle, okay, size, 0.1 up until 5 micron. So imagine, okay, participants, okay, try to close your eye, how it define, okay, it's a bit complicated. Try to close your eye, you can imagine a box of space. You can see the particles moving. Okay, I know it's tough, sorry. So I'll give you a box. Look at my slide, okay? So a 1 meter cube of box. I capture the particle. You can see the particles, okay? I make the particle visible. Okay, all these are particles, okay? Depending on how many particle counts in that box, then you define your ISO standards, ISO class, clean room standard. So the more higher class you enter, the smaller or lesser particle count. ISO 1, even the particle is very small, okay, or lesser. Okay, so clean room setup, okay. Some people who never worked in factory before, perhaps this so-called clean room is very stranger to you, but for me, I have experienced this. Okay, it's very clean. Okay, I give you a short video clip here so that you can understand a bit on what is called clean room. Hold on. Okay. Okay, I play the video now. Oops. Sorry, there's some technical issue. I replay the video. Okay, just a short video of illustrating how the clean rooms and the other design considerations. Okay, clean rooms. Of course, you can see a lot of people wearing we call smoke. Okay, or in my term last time when I was in a factory, you call monkey suit. Looks like a monkey when you wear these suits. Okay, so in your right hand side, you can see a blue. Okay, that nowadays because of COVID-19, to you maybe this kind of outfit no longer stringent because a lot of our frontline medical staff, they are wearing it. Okay, because of what? In industry, when you wear this, you are protecting the product. You don't want your product being contaminated. But in medical line, it's different. We are protecting human life against COVID-19. Okay, these are the difference. And of course, some people say, what? Products still need to be protected rather than humans? Okay, well, we need to think about it. Okay, but because the product is sensitive for particles that I mentioned. Okay, I'm not the expert in clean room. Don't intend to teach you how to set up clean room. But now we're looking into the screw. Okay, any special thing about this screw? Well, those who are not familiar with screw, you say, well, nothing. Okay, but if you look into a microscope, there are a lot of things can be deposited onto the screw. Okay, volatile organic contaminations or airborne molecule contaminants. It can be fiber, it can be ion, it can be other particles or even metal chips. Sometimes after what I call a screw manufacturing, there are certain microchips residing into the screw. So how to clean the screw? There's a typical process flow to clean the screws. Okay. Yes, you can't see very clear on these two processes. I purposely because this is a bit PNC with our partners. But don't worry, I'll show you this diagram. Some key features of the cleaning. Okay, you subject the screw under a special cleaning agent. There are a lot of cleaning agent in the market. Okay, then after that you subject them for pressurized rinsing few times depending on how much you want to clean. And ultrasonic cleaning is not normal ultrasonic cleaning, is elevated temperature at elevated temperature. Then after that you have a proper vacuum packing. So throughout this process, what more important? Okay, pull out my pen first. This environment, of course, because you want to clean the screw, this environment also need to be clean. It's a clean room environment. Okay, so just now we were talking about washing. The question is, how clean is clean? Okay, so cleanliness inspection from visual to visual assisted inspections. Okay, the normal inspection that a lot of company practicing is through visual. Okay, the inspector must be well trained in this case. Some visual enhanced tool, good lighting may be needed. No cheap foreign particles. These are very subjective. A lot of time. Sometimes we have some so-called a good argument with customer, this is acceptable or not, okay, stuff like that. But some customer use different method, like wiping test is widely adopted by a lot of clean room environments, according to some standard like ISO 14644, etc. Okay, But today I'm going to show you another testing method. Okay, the fastener, actually we can subject for a qualified lab using gas chromatography to check on certain organic compound. Okay, C16 or C7 to C14 in this detection range. Okay, organic residue, the weight per part. Then every part will have a drawing, a 3D drawing, will determine the so-called the surface area of the fastener in centimeters square. So after that, there is a formula to calculate the organic residue in microgram per centimeter square. So once you get this figure from lab, and then we have the surface area, okay, you just divide these two figures, then you got the organic residue, okay, in microgram per centimeter. So recently we have done one organic residue test for one of our projects in Penang. So where we supply certain fastener for the projects. The upper limit of the organic residue in this case is 9.7, okay, a power of -6 gram centimeter square. Okay, and based on the part that we have supplied to them, okay, as you can see, 3.5, okay, for the not even half of the upper limit. So all the sample been tested, passed, and supplied. Okay, so this is from organic residue testing standpoint aspect. So to customer, they no longer need to like deal with fastener supplier separately again and cleaning supplier separately or testing lab separately. They can actually deal with those who know how to get in touch with the expert partner. In this case, we not only supply the fastener, okay, we know where to clean it, we know the lab who can test it and then provide the right figure. Then we can calculate and then compile the what they call the reports to our customer. A one consolidated report streamline the supply. Okay, one-stop solutions. So in different perspective of cleanliness, now we look at this product. Okay, from supplier point of view, are we supply a single article? Okay, are we concerning about particle counts? Okay, those are the specs that should be given by customer. Okay, what are organic residue we are talking about, and then we'll determine the cleaning process. Okay, you know how to go about it. And then from customer point of view, it's product level, obviously. Okay, you're not looking at the single article. Aggregated, the total particle counts or the organic residue. And final, but also important, very important, assembly residue. You can generate it during your assembly, putting the product together. Okay, so to sum up, I'll give a summary of this on my webinar today. I sum up in 3 aspects in terms of coating and cleanliness consideration factors. First aspect is the design and product requirement. Second, you run a prototype NPI. Third, assembly and supply. So the challenges for coating and cleanliness, both of them are slightly different. Okay, I put into this model, this chart. Coating, the bigger this pie, meaning the emphasis is more in this aspect. Lesser means less. Why cleanliness and coating is different in proportional? Let me explain. When during the design stage, what you need to do for cleanliness, you only need to spell out the standards. Okay, what are the cleanliness level you want to achieve? But coating is different. Just now you follow my webinar earlier. We need to conduct the feasibility studies of the coating you selected, whether it's suitable for your product, for the application or environments, and whether there is a reaction between the two materials that you have selected with your products. So it's different. So the consideration is much more on coating during a design of product requirements. Okay. Okay. Second, I think the pie is almost the same between coating and cleanliness and NPI prototype. What you need to determine is the right test and assessment. So in this case, okay, just now I show you one of the example, the organic residue test, the right test. Okay, coating, we also have other test method, source grade test, as I mentioned, ISO 9227. Okay, and come to the last piece, assembly and supply. Cleanliness have a bigger concern. Why? Because in terms of processing and logistics, cleanliness need a special handling. But coating, what you define properly at the design stage, okay, you have done your proper assembly study, you have done a right test to evaluate them. So at the end, when you're doing supply, you just need to define the test plan, right? Okay, make sure the coating, this is what customer want, and then this is what we can supply, and so forth. Cleanliness is different. So if you put these all the constituents together, yeah, the guys with the back hair coming back again is a bit tough. Okay, it's a bit tough. So is there any expert consultations? Yes, of course. Like what today we share with you, okay, is one of the services that we offer from Bossard. The Bossard Expert Education. Today webinar is part of the expert education services offering. And inside this expert education, we have different topics, selected topic. This is a summary of topics. We have basic level, intermediate, and customized. Okay, today actually we have touched a bit on technical introduction to fastener. Okay, the full content will last for like 3 to 4 hours. So it's unlikely we can deliver all content through this webinar. And corrosion resistance, it's not talk about salt spray test, it's not okay, corrosion compatibilities, okay. So this is another big topic, intermediate level. And sometimes we have selected topics, special topics. In this case, you realize that we touch on the technical cleanliness. This is not available in our topics, but in case any customer like to know more, it's a technical cleaning and it's related assembly technology considerations. We can do that. Okay, with that, okay, I end my sessions. Okay, webinar sessions. Now I open up for technical discussion. Any questions? Okay, from anybody? That's all my webinar today. So I hope you enjoy these sessions. Okay, don't forget the last session series, third series. Okay, my name is Waibun, best known as Bun internally. So my contact detail in case you still have any questions. Okay, current professions, assembly technology expert, concurrent expertise. Okay, because I have exposure in risk management and business continuity management, you can contact me if you have query on this aspect as well. So take down my phone and you can visit my Facebook, Waibun Y. Ask any question that inside your mind. Okay, with that, I want to share the last piece of my slide. MCO. Yes, it's a movement control order. Okay, of course, you already revised to CMCO. But if you're able to switch our mind or action to MCO means must change, obviously, then the change is awaiting us. What kind of change? Well, depend on what kind of change that we want. So the change will become a chance, an opportunity awaiting us. So that's all for me. So I'll run the last piece of the closing short video. So stay tuned. Okay, stay charged, be healthy, and follow us on social media. Thank you. Bye.